In this video, we're going to talk about how to use your calculator to find key functions of all the functions that we're going to be looking at in the IBSL curriculum. So first off, we're going to start by looking at what you already have on your function. So on your functions, we can click on y is equal to, and you can see if there's already some pre-existing functions here. So I already have the function y is equal to x, and that can be visible when I click on my graph. I do see a line. Now, another thing that I see on my graph, and it might be similar to you, is I see this little dot here. This dot means that I have some things written in my stats. So in my stats list, I have some numbers in here, and I've graphed these and put it in my plot. So we do this when we do, for example, Pearson or Spearman correlations, and we want to see what it looks like on the graph. If that is your case, then what you want to do is you want to turn off all the stats plots. So how do we access the stats plots? Second, y is equal to, and you'll see that I do have in fact plot 1, which is here. So I want to make sure that I close all of them. So you can see that the fourth option is plots off. So we're going to close all of these, click enter again. Okay, so now when I go back onto the graph, I should not see that little dot. So now I'm ready to start. We're going to start today by looking at our first function, which is going to be a quadratic. So the function we're going to put into our calculator is negative 3x squared plus 5x minus 1. So I'm going to invite you to open up your calculators. So in your calculator, the negative is going to be this little button here, 3x squared plus 5x, and then minus 1. Good. Once you have this inputted, you can click enter, and then you can go onto the graph. If you can't see your graph, then you can put your window settings back to the default. So if you look right now, my window settings, I have negative 20 to 40. This is not the window setting, that's the original one. So what you can do is when you click onto zoom, you see that the sixth option here is Z standard. If you click on here, it's going to bring you back to the window setting, which is standard, which is always from negative 10 to 10 for both X and Y. So now we have something that's a little bit better to view our function. Another way of changing the window is playing around with the zoom. So if I click on zoom, I can decide to zoom in. And then you see that I now have a little cursor on my graph. I can move around my cursor to say where I want to zoom. And then you simply click enter. And it's going to zoom where you need it to be. Once we have a good window and we can see our graph clearly, then we can ask the calculator to calculate a variety of things for us. The first example we're going to do is finding the zeros, so finding the x-intercepts. So how do we find the x-intercepts? We go second function, trace, and then we see the 0 option. So the 0 option, this is going to be the x-intercepts. Notice that they ask for the left bound. So the left bound meaning you have to go to the left of whatever x-intercept you're looking for. And let's look for the first x-intercept right here. So there's two ways that you can input the left bound. You can simply click on your left cursor and it's going to bring you towards the left. And then you can click enter and then again your cursor towards the right and it's going to bring you towards the right. Then you click enter again. And then the last question they ask is guess. So guessing meaning you need to bring your cursor somewhere close to where you think it's going to be. So that's one method to find the zeros using the left and right buttons on your calculator. And they give you the zero, 0.232. Let's look for the other zero and let's use the other method. So again, second function trace, zeros. And if they ask for the left, well, I notice that this zero here seems to be between 1 and 2. So instead of going and using my cursor, I can simply input 1 as the x, click enter, and then it's between 1 and 2, so the right bound I can input 2 and enter. And then guess, well, it's somewhere between 1 and 2, right? So I can input 1.5 and click enter. And now it tells me that the 0 is 1.43. Another really useful tool on your calculator is this trace button. So when you click on trace, then you can use the cursor to move around your graph, and you can see the x and the y coordinates pop up at the bottom. So you can use this. If you want to know the y value when x is equal to 1, for example, well, you don't always need to use the left and right. You can simply type in 1, enter, and it's going to give you the y value as well. So trace is a useful tool when you're looking for y and you know what x is. Another tool you can use for that is the table. So if you want to see a table of all the x and y's, you can go second function graph, and it's going to pop up the table of values that you want. So all the x corresponds to the y's here. So that's another way that you can see this. Okay, let me go back to my graph. Now, another thing that we could do with our calculators is we could look at our maximum and minimum points. So again, we're going to go second function trace, and this time we're going to choose our maximum. Notice that they always ask you the same questions, left and right. So my maximum point, I can either use my cursor, go to the left of it, and then I see that the maximum point seems to be around 1. So the right, I can simply write 2. And then guess, well, guessing, you can either use your cursor or you can put in a number. I'm going to click enter, and I have my maximum point here. So if we recap what we've used so far, we've used our calculator to find the zeros, the maximum. Then we've also used the trace function to be able to find any point on our calculator. And we've used the table in order to see all the x coordinates match with the y coordinates. Good. Next, let's insert a second function into our calculators. I'm going to go to y2, and I'm going to insert the function 3x minus 10. Okay, I'm going to go back to my graph. I notice that the second function, which is in red, I really can't see it well here. So I'm going to play around with my zoom, and I'm going to zoom out. And I'm going to do that once. I still don't see it here. So I can zoom out again, and I can move this cursor down so that I can tell the calculator where I want to zoom out. Okay, that's good. We see both functions, but now we're going to need to zoom in. So if we zoom in, we can tell our calculator what we want. There we go. Okay, so now this is a really good window because we see both points of intersection here. So now the next part of the video, we're going to talk about finding the intersection between two functions. So we can go second function trace, and you'll see the intersection here. So intersection, again, they ask for, well, in this case, they ask for first curve, second curve. So the first curve, that's your quadratic, or regardless what you use, as long as you alternate. Second curve, yep, that's my red curve. I can click enter. Now, they ask you to guess the point of intersection. Notice that we have 2 points of intersection here. So you simply have to move your cursor towards the point of intersection you're looking for. Or you can use a specific x value. So I'm going to move it to this point, and I'm going to find that the first point of intersection is when x is equal to 2.09, or you can round this to 2.1, and then the y value is negative 3.7. Now, if we find the second point of intersection, well, we need to repeat these steps again. So I can go second function trace, intersection. The first curve is the blue one, the second one is the red one. And then guess, I can input a x value or I can use the cursor. If I input an x value, then I'm looking for probably something like negative 2. And then I click enter, and it's going to give me the second point of intersection, negative 1.43, when y is equal to negative 14.3. Okay, next up, let's look at horizontal and vertical asymptotes. In order to look at these functions, we're going to need to insert a function that has a horizontal or vertical asymptote. So the next function I'm going to ask you to input into your calculator is going to be 2 to the power of x minus 1. So we can have 2 to the power of x, and then you cursor to the right, minus 1. Now, I'm not really interested in having my x1 and x2 show up. So what you can do is you can move your cursor to the equal sign. And if you click on enter, you'll notice that the equal sign is no longer highlighted. So that means that it's not going to be visible on our graph, and only the exponential function y3 is going to be visible. So I'm going to click on graph. Okay, I see my exponential function here, but it's not a very good window, right? So we notice we have y shouldn't be much less than -2. So let's change the window a little bit. And I want to change my y minimum so that it's something like -3. And I'm going to click on graph. Okay, this is a better window for us. Now, if we're looking for the horizontal asymptote in this case, we notice that this function seems to be going on until infinity towards the negative x values. So we want to know what is this horizontal asymptote. One way of doing this is using the table. So if you go second function table, and then you scroll down, you scroll up, sorry, to the negative values, you notice that at some point the y value is always the same here. And this means that it's not equal to -1, but it's getting really, really, really close to -1. And your calculator can't do the rounding that specifically at this point on. So what it means is that when the x values are increasing towards the negative direction, then we're approaching -1. So your horizontal asymptote in this situation would be y is equal to -1. And finally, the last function that we're going to be looking at for today is a logarithmic function. We're going to have log in base 2 of x plus 7. Now, don't worry if you're not exactly sure what this looks like. We're going to have a full class that we're going to talk about all of these functions. And for now, what you need to know is how to put it into your calculator. There's a button on your calculator for log. However, if you click on this button, it's only going to be log naturally in base 10. Our logs that we want is in base 2. So instead of using this button, you need to go on math and then find the button or the position where you have log and then in capital letters base. You're going to choose this. Our base is 2. It's log of x, and then the plus 7 is outside of the brackets. Again, we're interested in only the log for this question, so I'm going to go ahead and remove the exponential function from my graph. If I go onto graph, I see nothing right now, and that's because the window is not appropriate. So I can use my zoom out and then to see where the graph is. Oh, okay, so the graph is up here. Maybe I want to change the window because we notice that all the x values that are negative are not useful for this function. So in my window, I'm going to change my x minimum. Instead of being negative about 40, I'm going to have it -1. Okay, now what's interesting about a logarithmic function is that there is what's called a vertical asymptote. That means that this graph continues down here until -infinity in the y direction. So most of the time for logarithmic functions, you'll notice that the vertical asymptote is x is equal to 0. But if you want to make sure of that, you can go into trace and then you go towards the left. And look at what happens with the x values here and compare them to the y values. As x is getting smaller and smaller, the y values there's still a y value here, right? And then x is very small here, 0.08, and we still have a y value. As soon as we have x is equal to 0, we don't have any y values. So that means that our function does not exist when x is equal to 0. And that's the whole definition of an asymptote. Our function cannot exist on this line, x is equal to 0.